All right, how's it going? Good break? How many wanted a longer break? Okay, cool. Wow, so we had 30 people registered for this section, and if you saw my notes over break, there were like 17 on the wait list. So theoretically, there should be 47 people here. So I started sending out some pleas for people to switch over to the afternoon section, and I believe at least 7 people did that. I don't know how full this section is going to be. If you have the option of taking the afternoon course, it's almost certainly going to be less hectic, less crowded, more relaxed.
I think it's almost impossible if you're in physics. And I think most of us are in physics.
So every day or certain days?
I have physics twice a week.
Right, but there's different days, right? Some people have calculations Wednesday, some have it on Thursday and stuff. So depending on your flexibility, right, you may find that it's useful to go to the afternoon section, except on the days when you have a conflict, and then come to the morning one. And if people do that on different days, that may even things out. We've still got an extra table in here from the final exam, so, and I have access to more chairs, so we'll make it work one way or another, but just kind of want to put that out there. And if you've already try to adjust and so on. I appreciate it. All right, so welcome to CSE 223. So the fact that you're in here means, among other things, that you passed 222. You survived 222, and that's not an insignificant accomplishment. Okay, 222 is arguably the most difficult course of this whole sequence. Okay, in my experience and in what students have told me, because you're tested and expected to be up to speed on programming algorithms, converting algorithms into code, being able to use tools like debuggers to make your code work, basic mechanical things like make files and tar and that sort of stuff. Plus you're learning recursion, which in some courses brings about up to a 50% drop rate. When recursion is introduced, a lot of people bail at that point, right? So everybody here survived the recursion onslaught. And data structures, right, which was the real emphasis of 222, and data structures are potentially, complex and confusing, and they force you to get into memory, which means ampersands and stars. And pointers and mallocs and segfaults and all that, and you've gotten through all of that, right? So the fact that you're in here today, I'm confident that everybody here is basically already a programmer, right, and has the ability to learn new languages and use programming as a tool to do all kinds of fun and interesting things. And so that's really what this course is about. So I'm not saying this course doesn't require any work, but you're going to find it probably a different experience from 222. 222, you may have had moments of survivor's doubt, like, can I get through this, or is this going to get any better, and so on. And this course is more kind of using what you've already learned to do and kind of playing with it. We're going to get into a lot of different things. We're going to be working with a lot of different packages that let us do some really cool things using our skill in programming. Yeah?
Are you bringing lab stuff to school day?
I am not. So, is that good? I put the labs together originally with this course in mind. And I may sneak one in at some point, but it's not on the module list on Canvas at this point. I think the labs are fun because, Java, for all that it does, you're still kind of stuck in a box. And we can do some really cool things with Java and hardware, but I think I'm going to bring them back next year. So you will miss that, unfortunately. But we will have some hands-on components similar to some of the stuff we did in 222, where we'll go over some concept and then you'll go to the board and work on it, or I'll give you handouts to work on in class and such. Yeah.
Do you still have our final exams from last year?
I do, yes. And you are welcome to come by and look at those anytime you like. And I also want to go over those exams tomorrow. I wanted to just make some comments, but not everybody's going to be here today, I suspect. So just wanted to run through some of the things I saw on that. So yeah, those are available. I have tons of office hours this quarter because I'm also teaching 250, so I have 3 lab hours. So I have lab hours sometimes at 8 a.m., sometimes at 9 a.m., sometimes at 10 a.m. Okay, so they're scattered throughout, and I think I might even have a 12 o'clock or an 11 o'clock office hour. Don't have 10 because I'm in here, but 8, 9, or 11. So hopefully everybody can make it during those times. All right, let me go through the syllabus, and then we'll start talking about details. So again, a lot of this you can read, but I want to hit a few highlights. So the text that I've listed for this is an online text. It's a free PDF. Don't read it cover to cover. Don't print it out. It's huge. Okay, but I think it's really well written. This person didn't just take the online documentation and print it in a book. They actually wrote a book on this stuff. So I think that's really useful as a reference. But we're doing Java. Java's been around for decades. Pretty much any reference is going to work. The online documentation from Oracle is probably your best resource, and we'll look at that repeatedly throughout this course to see details of things. So you don't need to go out and get a text for this course. On the other hand, I have in my office a bookshelf overflowing with Java books that somehow came to be my possession. And if you would like a hard copy Java book, come by and take a look and take 1 or 2 with you, and you can have it. They're books that lost their home, and I didn't see the point of throwing them out, so they're sitting in my office if you like having a physical copy. Let's talk about the course outcomes. Right, so these are the intended learning goals for this course. Object-oriented design and programming concepts. So we touched very briefly on object-oriented concepts at the end of 222. So that's what this course is about. Structures with extra stuff added into them. And the whole mindset that goes along with that, including modularization and so on. So that's a big takeaway is, experience in object-oriented programming and concepts, particularly using Java. We may do a little C++ 1 week towards the end, but mostly Java. Abstract data types, encapsulation, information hiding. These are concepts we're going to talk about as we develop an object-oriented mindset. So using those in different programs. More data structures, okay, trees, heaps, queues, stacks, hashes, things like that. So the things that we learned in 222, but in a different context here. Time and space complexity, that's basically the big O stuff, right? So how does this algorithm compare to that algorithm? What's the order of complexity based on problem size? Memory management, concurrency, synchronization, and related issues. We're going to be talking about, among other things, multiprocessing and parallel processing. And that's a very different world from working on a single machine where you have one stream of code executing. Because if you have 2 streams of code executing and they're trying to share resources, you can get into all kinds of interesting problems. For example, this reads a variable, and then it writes the variable with some modified value. But in between that, this other process thinks it's done the same thing. It's read this variable, made some change, written it, and now that change is going to get overwritten by this first process, right? Is that a problem? And if it is, how do you deal with it? How do you even recognize that that's going on? So we'll talk a lot about those kinds of issues. And we'll have a team programming assignment, the 5th one, as usual. So a chance to work in teams and do some group activities. All right, so grading, programming assignments, 30%, 5 assignments, 2 weeks each, except the last one, which you only get a week for, but that's the group one. I'll have some online quizzes, similar to the short answer kinds of things that you see on exams sometimes. And I have this labeled quizzes/attendance, 10%. I don't know if I'm going to take attendance this quarter. My idea is if attendance starts to drop off, I'll start taking roll. Okay, so if 90% of the people are coming to class, I'm okay with that because I know things happen. But if we get back to a point where half the people aren't showing up, right, that's problematic. So quizzes and attendance, 10%, some mix of those. Service learning project, 10%. We'll talk about that in detail. Midterm and final, 20%, 30%. So pretty straightforward. All right, and you can find grading scale and all that stuff on the ECS course policies page as usual. No changes in that. Course policies, academic honesty and plagiarism. We've talked about this occasionally. Yeah, I'm not going to talk about it now. It's a thing. I was reading some papers over break on the subject of why graduates can't program, and it was a bunch of recruiters, employers complaining about what they see as this trend that people are coming out of school with degrees in computer science and they can't program, and they're talking about why that is. And so that was interesting. And you know, I've mentioned this before. When I was looking around online, I found a place that would like write your programs for you for $5, right? And if you wanted comments, it was $10, which I thought was kind of cool. But you know, you send them your programming assignment and they write code for you. It's not going to be the same code they wrote for anybody else, or it's not going to pattern match, you know, against some database and stuff. And it's cheap, right? So you know, you can do that and you can get the grade and you can pass the course. But at some point, you know, you gotta learn to program, right? And as I say, the fact that you're in this course means that as far as I'm concerned, you know how to program, right? And now it's just sort of adding more skills, more languages, more concepts, things like that, more experience, right? But it's really the experience. So I'm not worried about plagiarism or academic dishonesty in here. Okay, I haven't seen any evidence of that. I have no reason to believe that's going on. It's just the sort of usual warning about if you're working in groups, and programming in groups is fun, right? I always enjoy that. I learned a lot. Make sure that you're not leaning too heavily on somebody else, right? If every time that you try to write another line of code, you gotta like ask your friend, you know, what did you do here, right? Then take a step back and work some more on that stuff alone, or come and talk to me or something. Just to make sure that when you get to the point of an exam where you gotta write the stuff on paper, right, you've already had experience with that. So no late work. Programming assignments, I'll take 24 hours late with like a 25% deduction. And that's just in case something happens, like your cat turns off your alarm and you miss the deadline and you have to turn it in an hour late. Right? It's better than a 0. Accommodations, we're in spring quarter, so if you feel like some sort of accommodation for test taking and so on would help you, chances are you've already explored this. But if you haven't, and we haven't already talked about this, read this over or look on the website or come and talk to me. If test taking is an issue, if you can't find a spot in the room where you can see what's on the screen, or you can't hear me talking clearly or something like that, right? Any sort of accommodation issue, let me know, or let somebody know, and we'll do what we can to make that more equitable. All right, so I'm still going to read the non-discrimination policy aloud here. So here's your one reading from PowerPoint moment for 223. Non-discrimination policy. Clark College affirms a commitment to freedom from discrimination for all members of the college community. The college expressly prohibits discrimination against any person on the basis of race, color, national origin, disabled veteran status, sex, sexual orientation, age, gender identity, creed, gender expression, Vietnam-era veteran status, religion, marital status, and presence of physical, sensory, or mental disability. The responsibility for and the protection of this commitment extends to students, faculty, administration, staff, contractors, and all those who develop or participate in college programs. It encompasses every aspect of employment and every student and community activity. So any questions or concerns about that, again, let me know, let somebody know. This course, any other course, it's campus-wide. And basically we want you to be able to spend your energies on learning and getting whatever you want to get out of your time here at Clark and not dealing with other things. All right, so let me do the same for course policy. So this one is the stuff that's more tailored to this particular offering this spring of 223. So my office is the same as usual. Office hours are on that schedule. During my lab hours, I may be in the collaboratorium, so come look for me if you don't see me in my office. We already talked about programming, so you know how to program, that's good. Syllabus, no extra credit. There'll be extra credit signatures for the SLP, but other than that, probably not a lot of extra credit. If something comes up, like a teaching demo or a volunteer opportunity, right, there may be a chance for some extra points there, but don't bank on it. Okay, don't skip programming assignment 2 and say, well, I'll just do the extra credit later. All right, so I would like you to come to every class as much as possible. All right. I know some people live far away. I know some people, this might be their only reason for coming to campus on certain days. And I am videotaping the courses. But we're going to do a fair amount of hands-on stuff at certain points. And we'll say things and do things here that will come back on the exams, or that you will need in order to get the best possible grade on a programming assignment. And even though we have this conversation every time, you know, I'll grade a midterm and there's questions that are left completely blank. And they're questions that we did in class, maybe for 2 days. And that everybody who was in class actually went through and did this thing. And, you know, and usually I even say, like, you'll probably see something like this on the final or on the midterm. And when people aren't able to even begin this on an exam, right, it's because they weren't here in class. So attendance is important. So as much as possible, I'd like you to try to come to every class. Emails. So I really want people to use Canvas this quarter. Okay, so another part of this course is sort of getting you more prepared for wherever you're going after this, WSU or UW, or, you know, whatever else is down the road for you. And so you're not necessarily going to be able to email your teacher at 1 a.m. and say, can you take a look at this? I'm having a problem with segfault, right? We don't get segfault in Java, but so I want you to start developing other mechanisms. One of those being something like a discussion group. Now, a lot of classes have some kind of online discussion or collaboration tool where people can swap ideas, ask questions, help each other out, and so on and so forth. I'm just using the discussion part of Canvas. I haven't done anything fancy here. But questions about what are we supposed to do for this, or what does it mean when the assignment says such and such, or, I keep compiling and then saying Java command not found, stuff like that. Start off with a discussion area on Canvas, and let's go from there. I'll read your emails if you send them, but I'm probably not going to reply until I see something on the discussion board. Okay, so I want to move in that direction. Exams, closed book, 4 pages of notes, same as before. More and more stuff about writing programming assignments on your own, so I'm not going to beat that to death anymore. Don't miss the midterm or final, that's always good. Programming assignments must be submitted correctly, so when we talk about PA1, I will talk you through everything that I've put in the assignment, which is already posted, including every aspect of what I expect submission-wise. Okay, and this is another thing I want to work on this quarter, is getting you to a point where you can absolutely follow a specification, right? So that, for example, I want you to submit a tar file. I want the archive to have this name. I want you to create the tar file in the following way so that your Java file is not in the subdirectory. I want you to include only Java files, not class files, things like that. So we'll talk about those with each program. And we're going to have different ways that we're submitting things. Programming assignment 1, we're going to do at the command line. PA2, probably at the command line also. By PA3, we'll be using an integrated development environment. So it'll be a different submission process for that. So we'll talk about those things as we go along. Programming style is also going to count for more in this course. Okay? Because we're moving into a mindset where we're not just writing a piece of code that we're going to turn in and then throw away. We're moving into a mindset of team programming, right? Not that we're working on teams in here, but where you're working for a project, for example, and you're developing a piece of a larger solution. And so, writing your code in a way that looks like what other people would expect to see becomes more important. So I'm not going to give you a 30-page guide style and say you have to put a space before the curly bracket and you have to move the semicolon to the next line and stuff like that. But we'll talk about a few standards that are pretty much universally accepted in Java programming. And we'll try to work with those. I think that's it. That's pretty much it. All right, so any questions or concerns on? Yeah?
Do you hear whether we use tabs or spaces?
No. But I'd like you to use something, right? Don't make everything left justified.
Will there be anything like ODPs?
I don't think I'm doing ODPs this quarter. I debated that for quite a while. It's just not that kind of subject, really. The ODPs were really kind of like stepping stones, and I just feel like everybody here already knows the fundamentals, and if you see, a Java statement to do something and it's got a different syntax from what you did in C, I don't think that's going to trip people up. So my current plan is no ODPs, no labs.
What sort of format will the quizzes be?
They're going to be online, and what does Canvas quizzes support? So mostly multiple choice, maybe short answer, fill in the blank. Yeah.
So will there be any other kind of homework, anything between the programming assignments?
No, programming assignments, online quizzes, and then midterm and final. I think that's it. Subject to change. Yeah.
Can you at least, would it be possible to at least get certain recommendations for like suggested reading out of the textbook or example problems that we can do out of there?
Yeah, probably.
Like some suggestion on how to practice for how you would understand this.
Sure. Yeah, I could probably post like practice problems or something. All right, any other questions? So we're going to be learning Java, right? But Java looks a lot like C. Okay, the syntax of an if statement or a for loop or things like that are pretty much identical to C. But Java is object-oriented, so we're going to work with objects. We're going to learn about objects and use those. We're going to work with IDEs, integrated development environments, and we're going to work with probably 3 different IDEs. IntelliJ, which is the one that I'm intending people to use for their programming assignments, is a fairly modern environment. So what's an IDE? Mplab is an IDE if you've done 270, right? MATLAB is in some ways an IDE. It's a single environment, right, program that encompasses things like an editor and a compiler and maybe a way to execute your code. But because everything is bundled into one program, it's cognizant of what you're doing. So most modern IDEs, for example, you start writing a line of Java, and if you misspell a keyword, it will highlight it for you. And it may even offer to correct it for you. If you start writing a function declaration, it will, as soon as you put in your opening curly brace, it'll create a closing curly brace somewhere down below. And if you start putting in the name of a variable, it'll like fill in a template for you. So it tries to do a lot of work for you. That can arguably make you more efficient, but it can also arguably make it harder to learn the stuff because you don't really have to think as much. And it's crazy how good some of these environments are, where you write something and it doesn't compile, but it says, you probably meant this. Hit Control-Enter to fix it. Or you hit Control-Enter and it says, which of these 5 things did you mean? You can just click on the one that you meant, right? So we'll work with some IDEs. So we're going to use IntelliJ as probably our main environment. I'll probably touch on NetBeans, which is a much older environment, but it's a very small footprint, very efficient IDE. And I will probably touch on Eclipse, which is what we used to use for this course. But honestly, Eclipse has gotten to where it feels really buggy to me in some ways. And I know I would get flamed for that if I posted that anywhere. Yeah?
Are we going to use Ant or Maven instead of Eclipse?
I don't think so. Well, I'm not sure what IntelliJ uses under the hood. It's not a makefile, right? It's probably Maven. But we're not going to actually work with those directly. Yeah?
So would you recommend we download IntelliJ?
Yeah, I would recommend downloading and installing IntelliJ. NetBeans we'll probably just touch on, and Eclipse, same thing. Last I knew, WSU was using Eclipse still, so I want to at least talk about that. But it just seemed like it's gotten harder and harder. I don't know, I went through last year's discussion section for this course, and every other discussion was about some new issue with Eclipse. A lot of issues if you were using an Apple. A lot of issues trying to use some of the plugins for Eclipse and so on and so forth. So, but definitely download IntelliJ. But you got some time before we get to using that. So we're going to talk about IDEs. We're going to talk about graphics, okay? Down to the level of, how do you draw a line by lighting up individual dots? All right, because that's basically what happens at the lowest level. You've got individual pixels and they're turning on and off different colors and intensities, and you create objects, all right? And usually we don't have to figure out which pixels to light up to draw a line from here to here, right? But it's useful to sort of see that level of things anyway. So we'll talk about graphics from that level all the way up to the level of GUIs. Okay, so being able to create something with push buttons and display areas and check boxes and text entry areas and so on and so forth. Way beyond anything we did with Zenity. Okay, Zenity is sort of like I desperately need a GUI, but I'm stuck in Bash kind of solution. We're going to work with a package called Swing, which basically lets you, I want to shadow 2 pixels thick on the top edge of this window kind of nuances. And along with that, we'll learn how to interact with hardware like mice right? So I want to do something when my mouse pointer moves over this part of my window, right? I want to run some piece of code. So we'll learn how to do that. And this will take us into a different type of programming that we can call event-driven programming, where we're writing a program that mostly isn't doing anything. Okay, it's just kind of sitting there waiting for things to happen. But we've said, if the mouse enters this area of the screen, go ahead and run this piece of code. And your program effectively wakes up when something happens. And if you've done 270, this is like interrupt-driven code. Okay, this is like the famous 3 lights blinking in sequence, and you press a button and something else happens. That's event-driven programming. We'll talk about networking. Okay, I'll sneak a router into the back room, and we'll have our own little local intranet, and we'll talk about how we can actually create connections to what are called sockets from one machine to another and pass information back and forth at a very low level. We'll also work with some web stuff. We'll see how to write a Java program that goes off and grabs a web page, for example. So higher level stuff like that. We might talk about speech synthesis. There's so many packages available for Java. If you want to hook a camera up to your program, if you want to do speech synthesis, if you want to bring in sound and analyze it in some way, right? There's packages to do all of this, and all we've got to do is learn how to interface to those packages, and then we just write code to do whatever we want to do, right? And this is why it's useful to be able to write code, because we can just tap into these other things that other people have already done for us. All right, and I already mentioned we're going to talk about parallel processing, multitasking, and all of the good things that go along with that. All right. Well, heck, it's a Monday. Let's see if I can get on the network. Yay, cool. All right. So you can do Java from the command line just like we do C, and this is actually what we're going to do to begin with. We're going to avoid IDEs, and if you're already doing Java and you already have access to your favorite IDE, I want you to go back and work on the command line anyway. Okay, because this is sort of the smallest footprint approach to writing code. So a few details. So extensions matter in Java. So your program is always going to be named something.java. Okay, that's what your source code is going to look like. And you compile by basically saying Java C, Java compile. And effectively, but not exactly, this creates something called name.class. It's more complex than that. But Java C will compile this and create something.class, and then to execute we just say Java, and we don't say name.class, we just say name, and that means name.class. Yeah?
So are classes the executables?
Effectively.
Okay.
So let's talk about what Java is. So with C, we write a program. It's a bunch of ASCII characters. We compile it using something called GCC, and it goes through various steps. It goes through a linker and all this kind of stuff. But in the end, we get this executable file, a.out or main or whatever we called it. And if you look at that file, it's a bunch of gibberish, but mostly it contains machine code for whatever machine we're running on. It would be x86 code for my laptop. It would be ARM code if you did this on a Raspberry Pi. But it's got ones and zeros that basically get dumped into memory, and you point the CPU and say, hey, run this code, right? And if I compile code on this laptop, which creates an x86 executable, and I try to run that on a Raspberry Pi, it will fail. It will say, I don't know how to run this. This was made for an x86, and I'm an ARM processor. Or vice versa. You make something on a Pi, you try to run it here, it says this isn't x86 code. Okay, so Java uses the idea of kind of a virtual machine. So here's your CPU. And sitting on top of the CPU is something called a JVM. That's a Java virtual machine. And this is a program that actually runs directly on whatever your CPU is. So on my x86 laptop, I have a version of this Java virtual machine that has the ones and zeros that my CPU understands. On a Raspberry Pi, there's a different JVM with ones and zeros that CPU understands. So this is something that you download and install for your particular type of hardware. But your class files get interpreted by the Java virtual machine. So the ones and zeros in here don't get loaded into the memory and executed by your underlying CPU. They get executed by this virtual computer called a Java virtual machine. So there's this layer in between the actual hardware and the code that you want to run. Okay, so that used to be a performance issue because you want to execute some instruction, and this program has to look at the instruction and say, oh, I'm supposed to increment this virtual memory location by 5, and it's got to go off and do that, and it was a huge slowdown, right? Today, it's pretty darn efficient, partly because CPUs are so fast. They're faster than we usually know what to do with them, and there's all kinds of tricks that have been used to make this thing more and more streamlined. So performance-wise, it's not as fast as a purely compiled program might be, but it's pretty darn good. And for us, it's more than sufficient. So one thing this means is that when I compile my program into what's called bytecode, bytecode is like, this synthetic executable code. When you compile your program into bytecode, it's always the same bytecode no matter what machine you're planning to run this on. Because this bytecode is not loaded into the CPU's memory, it's loaded into the memory of this virtual machine. So if I write a program on my x86 and I compile it into bytecode, I can take that bytecode over to an ARM processor like a Raspberry Pi, and the Java machine will understand that code and run it perfectly. And the other cool thing is, I've got a mouse here. It's got a wireless interface, and it's got, a certain number of dots per inch. And in my office, I have an old mouse with an actual mouse ball underneath and a wire going into the back of my laptop. And my Java code will work great with both of those. Right? Why? Because the JVM is doing all the heavy lifting. It's figuring out how to interface with the hardware. And if I run this on my laptop, which has a touch screen, right, the JVM understands that and it knows how to translate that into mouse events. And if I run it on a Raspberry Pi and I've got a mouse plugged into a USB, same thing, right? So this is where all of the kind of hard work of interfacing with the outside world takes place. Same thing with a display. I can have a little 640 by 480 black and white display. I can have a 4K display. Yeah?
That's why I say like a billion things run on Java.
Yeah.
Like your toaster and stuff.
Yep. Yeah. Because all you got to do is write a JVM for whatever system you're on, and you can run Java code. And it's fairly brilliant, right? And it was kind of a radical notion in the beginning, but it's become ubiquitous. I mean, everything is Java right now. Android is Java. Embedded devices are using Java. And that's cool. And it's a good reason for learning Java. Yeah?
I'd like to argue against that because a lot of things are using the JVM but not Java specifically.
True. Good point. All right, so let's do a hello world. So if I create something called name.java and I compile it, I will get a name.class. Okay, so here's our first convention. Class names by convention begin with an uppercase letter. And it doesn't really matter, right? I can make them all lowercase and that's fine. But when you're working with somebody's code, if you're used to seeing class names with uppercase letters and other things with lowercase letters, and you see a class name with a lowercase letter, it's confusing, right? And somebody else who is used to this convention, if they see your code and it doesn't follow this, they're going to have a harder time working with it. It's just, you know, you don't really need spaces between words when you write English, right? There's very few cases where you would have a confusion about what a sentence says, but we put spaces in between words because it's a convention. And if you're used to seeing spaces between words and you see something with all the stuff jammed together, it's harder to read, right? So these conventions are not like sacred, but they're there for good reason. Okay, so I'm going to make a Java program. I'm going to call it hello because it's going to create a class. So we've got 7 minutes here. So probably week 3 or 4 we'll still be figuring out exactly what everything in this hello world does. Okay, but we don't need to know what it does to be able to use it. So let me just write this and we'll talk through it as we go. So we're going to create everything as a class. Okay, a class is like a struct statement. We're creating a structure called hello. And because my file is called hello.java, my class has got to be called hello. It actually cares. Okay, if I call it something else, it'll say you got to put in a file named something else. And like a structure statement, everything is going to go in between curly brackets. Okay, so I'm going to write one program, and this is going to be my main program. And in C, we say integer main bracket, blah, blah, blah. And we have all these * stars or bracket or things like that. Okay, it's a little more reasonable looking in Java. But we need some magic keywords in the beginning. So public static void main. Think of it like peanut butter and jelly. You just got to have all 4 of those things there. And we'll talk about what each of those mean over time. And then, so this is a function, right, called main. And it's going to have a single argument, which is going to be a string. And we're going to want an array of strings, so I'm going to say string bracket. And I'm just going to call that string args, but it's just a variable name. And then I'm going to do a print statement. And our print statement looks really kind of like convoluted in Java. But it's system.out.println. And I'm just going to print out hello. And when you say print line with the ln at the end, that means put a new line at the end. So we don't have to do the \n every time we print. If we say system out print, then it doesn't have a new line, so it's like printf. All right, so that's our whole main program. And it's sitting inside this class hello. We got to talk about that when we get to objects, but this is Hello World 1.0. All right, so we'll compile it with Java-C. And that creates hello.class. And hello.class is mostly gibberish. It's got some human readable stuff. You can see our hello string about 2/5 of the way down the page. And some stuff that is meaningful to the JVM. But mostly it's computer speak. So we run it by saying Java and the name of the program, and it executes, and it prints hello. So that's your basic hello world. So let's just go a little deeper. Let's go ahead and print out the value. So args is an array of strings. String is a type of variable, so we don't have arrays of characters anymore. String is an actual variable type. And string bracket bracket says an array of strings. And my array of strings is called args. Let's print out the value of args bracket 1. And in print line, I can use this plus sign to tack things together. So I want to print out the words args bracket 1 equals followed by whatever args bracket 1 is. So I'm going to say Java hello, this is fun, and it's going to tell me args bracket 1 is equal to is. So let's look at args bracket 0. And args bracket 0 is equal to this. So this should already be making a little more sense than C might have, at least when you first saw this in C. Because args is an array of strings, I said Java to execute my program. I said hello, which is the name of my program. Args bracket 0 is this first string that I put after my program name. Args 1 is the second string. Args 2 is this third string, and so on. And if I just say Java hello, I get an error because I'm trying to print out args bracket 0, and there's no args bracket 0 because I didn't put any arguments on my command line. And so it's saying array index out of bounds exception. I tried to use index 0, and it tells me what line I was at. And that's a good thing. Yeah?
When you declared that function as publicly available, do you have to do that for each function, or can you do a public colon? And every function you declare after that is publicly available?
There's defaults. It's not a public colon like in C++, but there's defaults that you can use. Main is particular, though. Main has to be declared in a very specific way. For example, if I do that, right, that compiles just fine. When I try to run it, it'll say I didn't find a main method that was public static void main string bracket bracket args. Right, and it actually asks you with please define the main method as this. So main is just really, really picky.
When it threw that exception, it was able to say that it was on line 5.
Mm-hmm.
Is that the line number 5 stored in the .class file?
It's in the source code.
So if you deleted the source file, would it not be able to give you the line number?
I don't know. Let's find out. It's a really good question. So his question is, since it's referring to line 5, and I suspect it will still know that it's line 5, because I think that information is stored in the class file. Yeah. All right, so tomorrow I want to go through the 222 final, make a few comments on that, and then we'll start digging into Java in a more serious way.